Hi everyone, I'm Daniel from Hivemind Technologies, and with me is our principal engineer, Isaias, and we're going to have a small chat about functional programming versus object-orientated programming. Here at Hivemind, we are big champions of the functional programming paradigm, but we would like to discuss with you guys our ideas about how it compares with object-orientated programming. So, Isaias, you've created here a a small comparison chart that we're going to go through step by step. So would you like to talk through your ideas that you've presented here, starting with predictability, which you've defined as how well is a human supported to make high quality predictions about the program at right time and its runtime behavior?
Yes, of course. So maybe the first distinction is to have in mind FP is mostly talking about pure functions, and object orientation is talking mostly about mutable objects that send messages around to each other. And in terms of predictability, pure functions often give you an edge because the immutable nature that is also attached to those pure functions that we often work with give you a context that you can focus on, and you just have to focus on the inputs that are coming into your function, and you need to provide whatever needed to give the expected output. And if there's anything wrong to it, you can focus on this function. If you don't have the necessary things, you may have to add an argument. If the things that you have already in place, but you're still not able to produce the output, the error lies in this function and nowhere else. So you don't have to take a look at different parts of your program. Everything is nice and contained, and that gives you this idea and the concept of local reasoning. And that is very helpful in bringing this idea of divide and conquer into the design and implementation phase of the program. And that really, really helps. And on the other side, if you take a look at OP, that's a bit of a different kind of beast because everything is tied to those mutable objects, and objects have state attached. So you have to keep track of that state over time. And for me personally, it's a bit difficult to keep track over things over time. If they're adding up more than, let's say, 4 or 5 things at a time, it's getting just very complex. And for me, it's just very easy to keep things nice, small, in those boxes. And it helps me predict what the application is going to do at runtime when I write it. And that's where all this comes together. And I would give FP here a plus just because of this reasoning, local reasoning.
Yeah, when you talk about local reasoning as well, it perhaps could be the case that you're new to a project, you're entering into an existing code base, and it's your job to reason with the code base, figure out what's going on. If you've got pure functions, and hopefully with a well-written name as well, you can quite easily understand the function, perhaps just from the input and output types. Whereas with object-oriented programming, as you said, within pure functions, even though object-oriented programming has the plus that it can quite often kind of replicate real-world objects, the standard case of something like an animal extends a car, something like that, extends into a cat, I should say, not a car. So you could perhaps at first believe that you are reasoning with an object you can understand. Perhaps with a car, it can drive, it can steer and stuff like that. But because of that mutable state on the inside, perhaps changing without you being aware of it, you can never be fully confident in the output that you're going to get from a given function. Perhaps if you get a car to drive, it will fail because you didn't add the fuel to it yet, and you hadn't brought into the context of, a side effect state, a mutable state inside the object of needing to add fuel to it. Whereas with pure function, perhaps you need to state a parameter like that from the beginning as an input parameter. So that leads into, again, when you talk about local reasoning and understanding the function, goes into testability. When you want to test some code, perhaps if you're doing test-driven development, which we do here at Hivemind, you will be writing your tests first. With pure functions, this is much easier, as you've stated here. You just test the inputs and the outputs. Nothing is going to affect that. You can run that function 100 times with all manner of types of inputs, but you should be able to predict the output.
Yeah, and there's another thing also attached to the mutability of those objects that you need to keep track of. So if you have many objects, as you said, the car doesn't ride if you don't put fuel in it. So you need to be aware of, oh, I cannot push the drive button before I have put fuel to it. Otherwise, it will not behave as expected. Otherwise, you would expect the car to move forward, and it won't do that. And so you now have the necessity to keep track of the internal state of this car. So if there isn't fuel in it, you will not be able to drive. And that often leads in the test scope to this SPI, mocks, and all these other things that you know probably quite well if you've done object-oriented programming before. Then you need to know the internal state of that thing in order to predict what the test output is going to be looking like. Or if your application is behaving correctly at runtime. So all these details become apparent because of the necessity for observing the internal mutable state. Although the idea was to hide it away somehow with the concept of information hiding, but somehow it doesn't really uphold the benefits that it always promoted. So for me, this is a huge downside on that side, because you always have to keep track of those side effects, those mutations, and over time as well.
Exactly, yeah. And when we talk about side effects as well, this is something that can be real in the real world, in the production-ready services. Side effects are unavoidable. They are often needed, but functional programming paradigms have presented many solutions for this to represent side effects. So we've got the ZEO framework, which we're big fans of, and CATS as well, where you can model the side effects directly into the functions. So while they're still would not call them completely pure, but because they represent side effects, but they're much more controllable at this point. Whereas in object-oriented programming, side effects aren't as easy to model. I mean, more often than not, it's just mentioned in Java doc next to the function, as opposed to being explicitly stated as a type parameter in, for example, the ZEO type. So often as well, when you talk about mutable state, this is an issue that comes up a lot in scalability, trying to grow a small service into a large service, going from just small data batch processing to perhaps big data processing. Mutable state in concurrent systems is a massive pain and a massive headache, whereas in functional programming, there is no mutable state. You have, as you say here, sound primitives that allow you to scale almost seamlessly with parallel applications. You might have to share a mutable state, but there are again solutions to do that safely between different parallel applications.
To some extent, it turns into object-oriented patterns because you have all these different parts in your application which are mutable, and they're sending messages to each other which are immutable. So they're sharing information somehow, but they're never going to share a immutable piece of information in that sense that, let's say, pick the counter as the standard example. Two processors working on the same counter. So if one read and updates it, and both read it at the same time, then one update is going to be missing. That's like the standard example there. And that's just happening because they share this variable. Both are using the same counter. And if we're just sending around those updated counts, then you won't run into that problem. Prior professor at university always said, things go south when you have shared mutable state. And there is an easy way to fix that problem. If you don't have sharing, then mutable state is no problem. If you don't have mutability, sharing state is no problem. Well, the other is a bit of a more pathological case there, but these are the two routes that are mostly taken by those paradigms. And FP sits in that space where you just kick out mutability. And the object orientation is trying to focus on trying to minimize sharing so that it's very locally scoped. but you always have to keep in mind about the changes over time in those local scopes and make sure that they still align to each other. So it's still the same problem of keeping track of those state mutations over time, but now parallel, which makes it exceptionally more difficult for me to understand and comprehend. Might be difficult or different as well for others. But that's just a major plus for me why it's very easy to write parallel programs in FP in comparison to OOP land.
That's very true. And then going almost hand in hand with scalability, we get to composability as well, allowing you to plug different concepts together. In object-oriented programming, it's quite easy to reason with because you have large objects that represent, often in the case, real-world equivalents. So we said the car before, perhaps a database repository, or what else could you have? Some kind of factory thing for processing data in, data out. So usually you've got all the functionality in one big box, and at first that seems very appealing because you just know, oh, I just need an instance of that factory, and boom, I can process whatever CSV files I'll need. But then if you suddenly need to combine that with perhaps event-driven architecture, you need to populate something to a Kafka topic or send things to a database or to Spark. Suddenly you might be having conflicts between two large objects, whereas in functional programming, everything, as you say, is much more composable. So could you talk about that a bit, please?
Yes, of course. So the functions, if they're all pure, that is the necessity. Some languages support that you cannot write impure functions. Scala, for example, is not in that space, but it gives you a lot of frameworks in order to help you be disciplined and explicit about it, like you said with Zio, for example. And given this sound primitives, every function is pure. At least you can easily identify that it is pure. And then it allows you to compose those pure functions to things that are, again, pure. So everything that we stated before, like the scalability, then applies to it by mathematical guarantees. So you just have these very small components, these primitives, that when you stack them together are still sound. They are still safe to use, easy to test, scalable. And on the other side, if you take, let's say, the patterns that we may already have heard of in the OOP land, like singletons, visitor, observer pattern, all those kind of things helped really name and identify things and patterns that we see in the real world. But those are primitives in the OOP land on its own. They're built of objects talking to each other in a specific way, and you have to be disciplined and experienced in order to bring those together. And if you have multiple patterns that you need to apply together, the question comes really quick up, does it really do what it should do? Am I doing it right? And there are often patterns of patterns, like where you see, oh, I have seen someone doing these 3 patterns together in order to solve a specific problem. Then you might have a chance to just replicate that. But oftentimes it's going to be a lot of guessing or defensively working around it to make sure that it's really doing what it's supposed to do. And on the other side, you just plug it together and it will just transitively inherit all the properties from bottom up. So the biggest things that you build are always going to be sound in the terms of the things that you chose to build it up.
Mm-hmm. When you talk there about the different patterns that you can use in object-oriented programming, if you know them well and can compose them quite well together, you could create a very sound application. But that's contingent on the fact that if you understand them well, which comes to the learnability topic, how easy is it to learn each of these paradigms. So you talked about a lot of patterns there. That represents a lot of things to learn. And oftentimes, though, I feel like the industry and the universities are a bit guilty in leaning towards object-oriented programming as perhaps the easy way to get into programming. Certainly that was at my university, where Java was the go-to language. And so we were taught Java throughout my 3 years of my computer science degree, and it was the lens through which we learned computer science was generally through Java, learning even database applications as well, and algorithms and everything. we had one course, one term on functional programming where we learned Scala, but that came and went quite quickly, and it was never mentioned again. Often it is seen that functional programming has a higher entrance barrier, but we were discussing, and you believe perhaps this is the entrance or the barrier is only high because people start learning through imperative programming languages or object-oriented programming languages. And if they started with a functional programming language, you think then it would be perhaps not much harder or almost as easy as it is with imperative programming languages.
Yeah, I'm almost citing a professor from a university there again, but yeah, he said like it would probably be much easier if we would have FP natives instead of OOP natives, as you're stating there. Exactly. I think if you start learning FP and then move over, OOP seems a bit difficult to you, and similarly the other way around. And because the industry is much more in that space of having nurtured OOP so long, we have this different situation. But from the abstractions, I would say the entrance barrier for just pure functions is a bit higher because you have to understand the notion and the concept around the side effect and what that actually means. And that is like a high entrance barrier. And if you compose functions that return functions into those patterns that we know from OOP that have specific names, but they're just completely built different from these primitives of a function returning functions in the FP world, it's a bit more difficult to grasp at the beginning. But yeah, it's because of the imperative nature, I think, that it's still the first way to get into programming, because computers just work that way. So you have this processor, you send them instructions one after the other. And if you start learning it from the ground up, it's just very natural to start there. Although I think as humans, we more think of processes that are somehow interlinked and sending messages into, let's say, those functional blocks that then work together in composition. And you more get into the declarative space and say, this is what I want, and I don't care how you get there. And that's where the FP comes in. It gives you more this, let's say, declarative approach where you say, I want this and this and this. I don't care how the instructions are going to look like. You send them to the computer, and that's going to figure it out underneath. But it's just another abstraction that comes in there.
Mm-hmm. And going hand in hand with learnability, you've highlighted discoverability. And actually now we're getting into more pluses for the object-oriented programming side. So in classic OOP, you said once you have an object and you can send messages to it, and you can quite easily discover its API with modern IDEs like IntelliJ. You just do dot, and then boom, you've got a full list of everything that it can do. But you believe that it might actually be harder to discover on the functional programming side.
Yeah, so if you don't know what you're looking for, oftentimes you start with a new subject, and in OOP, you have an object that is giving you new aspects to an underlying API, and you just ask the object, hey, what messages can I send to you? And that's the dot. Usually you dot your way through, and then in the end, you have your thing or understand what you want to do. So it's easy to discover. It's also easier for introspection tools to make this work for you, to provide you with that information. On the other side, you have this huge space of functions that you maybe don't know of, but want to use, and then you have to scan all that through, and makes it a bit difficult at the start to really know what you're looking for. And if you don't know what you're looking for, it's making it even harder. So if you have an idea, then okay, you may work your way through, and there's search tools like Google for Haskell that you can type in what you're searching for by type. That is giving you a similar sense of it, but people are not used to use that, and it's not usually integrated into IDEs. So it's just far away from that, let's say, easy discoverability mode that you get from OOP languages. So yeah.
I do think that there are solutions in FP, but again, it comes back to learnability. I think it comes down to good module design. Perhaps something I've been working on more recently is having well-defined modules with a clear entry point. into that module. So in some ways, it becomes a bit object-oriented programming again, because instead of an object, we've got a module and an entry point, a clear, perhaps one or two clear functions that kind of define the top level or the entry level to perhaps a network of smaller functions underneath, but the main core domain logic that you want to deal with at the top of that module, that's easy to discover. But this comes down to good code writing patterns and stuff. That's something you need to learn.
Yeah, and maybe something to point out as well, it doesn't need to be dogmatic. So oftentimes both of these paradigms can be combined, and languages like Scala allow us to do that. And oftentimes it's good maybe to look what particular topic is greener on which side of the fence, and maybe go and linger around a bit here and there. And in this case, the Fluent API style is oftentimes replicated in the FP world to just have that sense of the object-oriented discoverability mode. And then you get into this design space where you can provide your module with the necessary entry point, and from there everything branches off, and then you have the discoverability and FP as well. But it's a bit on the edge, so it's taking like a lingering sidewalk between the two sides of the fence.
Yes, well, that's a key word as well, dogmatic. That's something we try not to be here at Hivemind. We accept all the pros and cons of any tools that we use, and if a certain pattern from the OOP world is beneficial, like I'm quite a fan of the builder pattern. It's quite simple and quite easy to reckon with, I feel. And if that seems to be the easiest solution, the more understandable solution, and then I will perhaps use that instead, because again, first and foremost, I want to write code that's easy to understand, easy to maintain. So yeah, we don't have to be dogmatic. We can embrace patterns from other paradigms as needed.
Yeah, maybe one perfect example could be this runtime overhead. So since the computers are inherently imperative by design, sometimes it becomes very just necessary to go down that route and take an imperative approach. There's like algorithms, lots of them, you probably know, and some of them are iterative by nature. So they just expect you to work on a piece of information over and over again. And if you just create always new objects, it might not be efficient. So keeping on the same data structure in a small confined set of addresses on the RAM is going to be the most efficient way to deal with it. So you always change state on that particular piece of your RAM. And then you're basically using mutability and imperative style to implement that algorithm. But if you have something that gives you leverage to maybe pack this whole in an, let's say, pure API. So you send in inputs, the algorithm is doing its thing in an imperative style. You leverage the fact that this is now running very smoothly on the computer, but the output is going to be generated eventually, and then you turn it back. That is where these two things are, I think, marrying very well together, and being not dogmatic, taking the best of both worlds, and then hopefully providing the best value for your money.
Definitely. I mean, if you look inside the Scala API, so the collections API, a lot of the functions there, a lot of methods do use mutable state, such as collection sort, I believe, does use the dreaded var in Scala for a variable instead of an immutable data structure there. And then something we've touched on before, the popularity of each of these paradigms are mentioned here. I think a lot of universities and such tend towards object-oriented programming simply because they believe it's easier to introduce undergraduates into the programming world through OOP instead of through FP. And right now, if you look at the TOB index, for example, imperative languages are king, Python, and then follow that C, C++, I believe, are the next most populars, and then Java, as always has been for how long now has Java been around? A decade and a half, 2 decades. It's pretty much the king for most back-end software development. So because of that ongoing popularity, functional programming languages, or languages at least that try to implement a functional programming paradigm first, and such as Scala and Haskell aren't nearly as popular.
Sure. Yeah, I think it really boils down to at the beginning, it was a lot of nurturing on the academic side of things. So a lot of research has been flowing into FP, and the abstractions just were a bit daunting maybe for beginners. And so the whole industry shifted from imperative procedural into object-oriented programming. And since you always have the ability to go imperative all times, things are still mutable per se in object orientation. It was just very natural for the, let's say, big community of procedural and imperative programmers to jump on the OOP bandwagon, then jump over to the FP. And also compute was expensive and the amount of data was smaller. And now things have changed. So more people get into larger and big data projects, try to make return on invest on those things. And the necessity is just getting more clear that you need to process large amounts of data. And then FP has a very, very big shining future in that space, because that niche is very easy to tackle and it's getting more and more adopted in a wide space. But big industries have been nurturing OOP for so long. There was this old community which merged into OOP, which still used their own tools, the imperative style in OOP, adapted it. Just, I mean, the debugger, how oftentimes did you use that recently? Most times it's very predictable. So I personally don't see myself oftentimes using mocks debuggers anymore, because the application is just so predictable that I don't often run into issues where I need to pull out the debugger. And but this is a whole set of tools that has been developed and people are used to it. And if they're used to it, they want to keep using it. And so that whole thing, machinery, has been just keeping itself alive because of that, I think. That's just my opinion. And yeah, I think new generations will more and more get FP native and grow into it. And that's probably the way it goes.
We can hope so, for sure. I mean, I was introduced to Scala, 4 years ago, and I think it took me at least 2 years to really kind of get out that object-orientated mindset a lot of time when writing code. And when you talk about the debugger, that is a terrific skill if you're writing object-orientated codes, Java or Ruby. But since working with Scala now, Scala code bases, I primarily use the debugger when handling legacy code bases, which perhaps aren't such purely functional code bases. Then the debugger does still become very necessary. But writing much newer code, perhaps with something with cats or Zio, I can much more often just simply rely on the types and the compiler to handle everything, to spot bugs for me long before I've even hit the run button. So that is very, very true as well. So thank you very much for your time, Isaias, and it's been a pleasure talking with you as always.
Yeah, thanks, Daniel, for that.
And anyone else watching, please see the Hivemind website for more of our articles discussing all manners of technology and adjacent topics. And yes, if you're interested in more, you can check us out at Functional Scala. The videos will be up on the ZVerge YouTube website soon. And we look forward to seeing you again in the future. Thanks for now.